Okay, I have here two different kind of simulator. So this one, JS-VISG-M-S. So this is, we can simulate milliamp and voltage. So the other one is WZ signal CVS, which can simulate as well as can read milliamp and voltage. So this one is only a power bank to supply your simulator. So first, I connected, yellow one is for in. So in. So the output of this, for example, EI means the analog input for current, and this one analog output for voltage. I mean analog output for current. So first we will check the milliamp. So milliamp, we need to put the alligator clip on the analog output for current. So EI0. So and then we're going to put the yellow alligator clip into your input for your WZ signal CVS. So whenever I will change the value, so as you can see, there is a 4.04 milliamp deviation, which is very less. So it's almost accurate. And then I will try 4 milliamp. So 4 milliamp is 3.97. So you have 0.03 milliamp deviation. Is very less. So I conclude that this is almost the same, accurate. So now let's try with our multimeter analog to check if the reading for this is the same on the reading on our analog tester. So we'll put the value to milliamp, the selector into 25 milliamp. So we're going to test if it's nearly the same or the same, almost the same. So as you can see, it's reading from, so 25, so you will read from here. So it will be almost in the center of 0 to 50. So I can not middle, but you see it's almost the same reading from the simulator. So it's 4. I can say it is 4 since this is 2.5. So this is 3 point something. So 4. So I can say it's the same. How about 10 milliamp? So 10 milliamp, as you can see, and also here is 9.98. So it's 0.02 deviation from our reader. So let's check. So as you can see, 25, so it's almost in 10 in 100, so meaning that is 10. So 9.9 something, it's almost the same. How about the digital, this one? So let's see if it's also reading the same. So put the selector into MA, which is milliamp. Okay, so let's see. See, 9.99. So as you can see, it's almost the same. So how about the 24 milliamp? So I will change 24, 20 milliamp I mean. So now it's reading the same. So I will measure also. See, it's 20. How about the analog? It's almost in 200, so I can say this is 19. 19.7. So okay, so this is good. How about voltage? So I will change this into voltage. So now it in 10 volts. 10 volts. So I will change also here from yellow alligator clip into red. So I will change this into AVO, which is analog output for voltage. Okay. So and then I will also change this into vol. So as you can see, there is a vol now. Vol. So now we read 10 volts from this simulator. So it's the same. How about here? I will also change into DC. Now it's in DC. So I will measure. No, I mean this one. See, 9.97. So it's also nearly accurate. How about from our analog? We'll put to the range 50 DC. So 10. So exactly 10. So I can say these simulator are good to use. So it is safe to use. It is although there's no certificate for calibration, but I can say this is good for testing and calibrating any equipment and instrument.